Good evening, ladies and gentlemen. Welcome to tonight's edition of Behind the Science, Adams Edition. I'm your host, Dakota. We're going to start off with the man who got the ball rolling with Adams. His name was Democritus, and we've got an exclusive interview with him tonight. Austen, how's it going over there?
Thank you, Dakota. I'm here with Democritus. So, what was your theory about the atom?
Well, you see, Austen, I believe atoms make up everything. I believe that atoms are the smallest unit of all matter. They are indestructible and indivisible.
That's interesting. So, how do you feel about Aristotle's comments saying that your theory is flawed?
You want to know how I feel about Aristotle?
Yep.
You really want to know?
That was the question.
I'll tell you what. That sissy Aristotle's watching this right now. I'm coming for you, buddy. I'm coming for you. I'm gonna get you.
Well, thank you for your time.
Don't mention Chad.
It's Austen.
Whatever.
Back to you, Dakota.
Wow, that was downright scary. Very powerful words from a very powerful man. Well, anyways, next on our list we have John Dalton. Hopefully this interview goes a little bit smoother. Austen, back to you.
Thanks, Dakota. I'm here with John Dalton. Mr. Dalton, could you tell us about your model of the atom?
Why, yes, I can. You see, I took Democritus's ideas and beliefs, even his hypothesis, put all those together, and I created my own atomic model.
Could you show us that model?
Why, yes, I can. I have it right here. Would you look at that?
Look at those details.
Now, Austen, I'm glad you decided to bring up the details of this atomic model because I put a lot of hard work and effort into this. And for you to go and say something like that. All the years I used to walk around my town building this, and everybody in my town used to say, "Oh, there's old John Dalton playing with his balls again." Are you proud of me now, Dad? Are you proud?
Well, there you have it. John Dalton and his model of the atom. Back to you, Dakota.
Wow, what a truly inspiring story of one man's hard work and determination to overcome adversity with nothing more than his brilliant mind and some balls. Well, anyways, next on our list we have the Plum Pudding Man, J.J. Thomson. And back to you, Austen.
Thanks, Dakota. I'm here with J.J. Thomson, and he's going to show us his atomic model, as well as demonstrate the experiment that led him to discover the electron.
Oh yes, I believe you're talking about my plum pudding model.
Yeah, why would you call it that?
Well, you see, Austen, where I come from, pudding isn't exactly pudding.
Alright. So, about that model.
Oh yes, actually, you want to see a picture of my model? I have one right here. Right here's a nice, lovely picture of my wife.
No, your atomic model.
Oh, the atomic. Oh, my bad. Thought you guys want to see a picture of my wife.
Well, she's lovely.
Thank you. Right here is actually a picture of my atomic model. As you can see, I took John Dalton's ideas of what the atom was like, and after I discovered what electrons were, I figured the electrons had to be placed somewhere inside the atom, with all the extra empty space being positive material, of course.
Great. So, do you want to show us your experiment now?
Oh yeah, I can do that too for us real quick. Starting off, I have my homemade cathode laser beam. It's working. Anyways, this goes great with my stronghold jar that catches cathode laser beams. Anyways, I'm going to show you how this works right now. You start the laser and you stick it in there, and you'll notice that we have a positive magnet on this side and a negative magnet on this side. And as you can see, the cathode laser is getting pushed away from the negative side towards the positive side. And if you learn anything in school, you'll know that opposites attract, which tells me that cathode lasers are negatively charged, which shows they have electrons in them. And from there, it's pretty simple. I guess you could say that I figured out that all matter consists of electrons, and pretty much easy as cake the experiment was, or as I like to call it in my home country, plum pudding.
Alright, well, thank you for your time and the experiment.
Don't mention it, Steve.
It's Austen.
Whatever.
Back to you, Dakota.
Wow, Mr. Thompson is quite a brilliant man. I wonder where the world would be without him today. Well, last on our list we have Ernest Rutherford. Austin, how's it going over there?
Thanks, Dakota. I'm here with Ernest Rutherford, who's going to explain his experiment to us that led him to create his atomic model. Ernest?
Yeah?
Could you explain your experiment to us?
Oh, yes, I can. In order to understand my atomic model, you have to understand first that I used the experiment to create my atomic model. And with my experiment, I obviously couldn't bring all my equipment here to demonstrate it for you guys like J.J. Thompson could. But I brought a picture that I drew by hand, and I've got more willing to show it to you guys. Right, here it is. I really can't tell by this picture, but I created a sealed tight vacuum compartment in which I was forcing alpha particles at a thin sheet of gold. And what I got from the experiment was that almost 80 to 90% of the particles were traveling through the gold and onto the other side, and maybe just a few here and a few here were ricocheting off. And because of that experiment, I had hypothesized and pretty much proven that atoms are mainly empty space. And because of that, I'm now going to show you my atomic model that I had created because of the experiment. As you can see, right here is the nucleus, and the ones that bounced off in my diagram were because they had hit the nucleus originally. But all the ones that went through was because of all the empty space. And as you can see by this, there's plenty of empty space, positively charged nucleus, and then the electrons, which are traveling around the nucleus in an orbit. I think that they travel around the nucleus in orbit just like the Earth does around the sun. So that's just all I have on the subject.
Wow. That's interesting and complicated. Well, thanks for being here. It was a pleasure.
Don't mention it, Andrew.
It's Austen. It's not that hard of a name. It's common, actually.
All right, Brett.
Wow, what a power-packed day of learning about science and atoms. That's our episode of Behind the Science for tonight. Tune in next week as we investigate the mystery of Bigfoot. I had fun tonight. I hope you did as well. Signing off for tonight, Dakota Applegate.
I live for the applause, applause, applause. I live for the applause, applause, live for the applause, applause, live for the way that you cheer and scream for me.